February 21st, 1945, Iwo Jima. The volcanic sand was still warm from a morning bombardment. Black smoke drifted low across the broken ridges north of Mount Suribachi. The air smelled of sulfur, cordite, and burning canvas. An American M4A3 R3 flame tank crawled forward at walking speed. Its steel hull was scarred from shrapnel. Fresh weld seams reinforced its sides. The Marines followed behind it, crouched low, rifles angled toward the jagged openings in the earth. Inside a concrete-lined cave, a Japanese officer watched through binoculars. He had seen tanks before. Shermans could be stopped. They had been stopped. Grenade bundles, satchel charges, men willing to run beneath the tracks. He gave the order. 3 soldiers rushed from concealment. Grenades struck the tank's hull. The explosions flashed bright against dull olive armor. Smoke burst outward. Sand lifted into the air. The tank did not stop. Its engine continued its low mechanical growl. The turret shifted. A long metal nozzle dipped toward the cave entrance. And then the flame came. In that moment, doctrine met reality. And the reality was something Japanese officers across the Pacific would soon fear. By late 1944, the Pacific War had entered its most brutal phase. 3 years earlier, on December 7th, 1941, the attack on Pearl Harbor had drawn the United States fully into the conflict. What followed was not a single front, but an ocean-spanning struggle across thousands of miles of jungle, coral, and volcanic rock. The early Japanese offensives had been swift. The Philippines fell. Guam fell. Wake Island fell. British and Dutch colonies across Southeast Asia collapsed under coordinated assaults. But by mid-1942, the tide began to shift. At the Battle of Midway, American naval forces crippled Japan's carrier strength. The long campaign at Guadalcanal bled the Imperial Japanese Army and Navy in a grinding war of attrition. The strategy that followed became known as island hopping. Instead of attacking every fortified position, American planners targeted key islands that could provide airfields and naval anchorages. Each captured island became a stepping stone toward Japan itself. But with each advance, resistance hardened. By 1944, Japanese commanders understood they could not win a conventional maneuver war against American industrial capacity. Instead, they shifted doctrine. They would trade space for time. They would fortify islands not to repel invasion at the shoreline, but to bleed the invader inland. On Saipan in June 1944, this transformation became visible. Rather than massing forces at the beaches, Japanese troops constructed deep defensive networks, interlocking bunkers, reinforced concrete pillboxes, concealed artillery positions, and natural caves carved deeper by engineers. Every ridge became a fortress. Grenades and small arms fire became tools of close-range survival. Japanese infantry doctrine encouraged aggressive anti-tank action. Soldiers were trained to wait until armored vehicles passed, then rush from concealment to attack vulnerable areas. Grenade bundles were tied together for increased blast effect. Satchel charges were hurled beneath tracks. Some soldiers carried magnetic mines. Others used improvised explosive packs secured with cloth or rope. Against early war light tanks, these tactics sometimes worked. But by 1944, the primary American armored vehicle in the Pacific was the M4 Sherman. It was not invulnerable. Its side armor could be penetrated by heavier anti-tank guns. Its tracks could be disabled. But in jungle and volcanic terrain, artillery pieces were often difficult to conceal and supply. Infantry explosives remained the most accessible anti-armor tool available to Japanese defenders. The problem was structural. Japanese industry could not match American output in armor or mechanization. By late war, many island garrisons lacked sufficient anti-tank guns. Ammunition was limited. Replacement parts were scarce. What they possessed in abundance was manpower and doctrine that demanded sacrifice. The United States, by contrast, had turned its industrial might towards solving battlefield obstacles. Engineers analyzed bunker systems encountered at Tarawa in 1943. They studied cave networks on Saipan and Tinian. The conclusion was stark. Traditional high-explosive shells were not enough. Many bunkers survived naval bombardment. Artillery often failed to penetrate reinforced concrete. Japanese defenders would remain sealed underground during shelling, then re-emerge once infantry advanced. Close-quarters assault was unavoidable. Flamethrowers had already been used by infantry units. Portable models, such as the M2 flamethrower, could clear trenches and bunkers, but their operators were exposed and heavily targeted. Casualty rates were high. Commanders needed something that could bring fire directly to fortified positions and survive the grenades thrown in response. The idea was not entirely new. Flamethrower-equipped tanks had been experimented with earlier in the war. But in the Pacific, the concept took on urgency. The terrain itself demanded it. Iwo Jima, the small volcanic island located roughly 750 miles south of Tokyo, was never intended to be held lightly. When American forces prepared to invade in early 1945, Japanese General Tadamaki Kurabayashi had already transformed the island into a subterranean labyrinth. Nearly 11 miles of tunnel-connected artillery positions, machine gun nests, and command posts. There would be no banzai charges at the shoreline, no reckless counterattacks on the beaches. Instead, Kurabayashi ordered his men to remain hidden, to fire only when targets were certain, and to conserve ammunition. Every cave entrance was angled to create interlocking fields of fire. Mortars were pre-sighted, machine guns were assessed, and, crucially, anti-tank teams were assigned to sectors expected to receive armored assault. By February 19, 1945, when U.S. Marines landed on Iwo Jima, the island did not erupt immediately. For nearly an hour, the beaches seemed deceptively manageable. Then the defensive network opened in full coordination. Tanks that attempted to climb inland encountered soft volcanic sand that slowed movement. Engineers laid matting to stabilize routes. Armored units became essential for breaking through hardened positions. But every time a Sherman approached a bunker, Japanese defenders prepared to do what they had been trained to do: wait, rush, and throw everything they had at its steel hull. For years, grenades had been reliable companions in close combat. Now they would meet reinforced armor, improved ammunition stowage systems designed to reduce internal explosions, and something even more terrifying, tanks designed not merely to fire shells, but to project liquid fire directly into the earth. And the psychological impact of that shift would prove as powerful as the weapon itself. The decision to mount fire onto armor was not born in a laboratory. It was born in frustration. By 1944, American after-action reports from Tarawa, Kwajalein, Saipan, and Peleliu carried a recurring theme. Naval bombardment suppressed Japanese defenses, but rarely destroyed them. Concrete pillboxes absorbed direct hits. Volcanic rock protected cave entrances. Artillery could collapse tunnels, but only with precise angles that were rarely available under combat pressure. Infantry assaults alone were costly. The solution required something that could approach within yards of a bunker and force its occupants out, or eliminate them without requiring Marines to stand directly in front of the firing slit. Flame was the answer, but flame needed protection. Early experiments with armored flamethrowers began in 1943. The U.S. Army Chemical Warfare Service, working alongside the U.S. Navy and Marine Corps, developed conversion kits that could replace a standard Sherman's main gun with a flamethrower system. The most widely deployed Pacific variant became the M4A3R3, often nicknamed Zippo by crews. Unlike infantry flamethrowers, these systems were fed by internal fuel tanks mounted inside the hull. A pressurized mixture of thickened gasoline, similar to napalm formulations, could be projected in sustained bursts. Range mattered. An infantry flamethrower typically reached 20 to 40 yards under combat conditions. The tank-mounted systems could exceed 100 yards, depending on wind and pressure. More importantly, the tank itself could survive long enough to get that close. By late 1944, additional modifications improved survivability. Wet stowage ammunition racks reduced the chance of catastrophic internal explosions. Extra armor plating was welded onto vulnerable areas. Spare track links were bolted to hull sides as improvised reinforcement. Japanese grenade tactics relied on proximity. Soldiers would often allow a tank to pass, then rush toward it from blind spots. They aimed for tracks, engine compartments, or thinner side armor. Grenade bundles were created by tying multiple Type 97 fragmentation grenades together, increasing the blast effect. In some cases, soldiers carried satchel charges weighing several kilograms. These methods demanded extraordinary courage. They also required the tank to stop, or at least hesitate. On earlier battlefields, tanks sometimes withdrew after sustaining blast damage. A disabled track meant immobility. An exposed infantry screen meant vulnerability. But the newer Shermans in the Pacific were increasingly supported by coordinated infantry tank teams. Marines moved tightly alongside armor, scanning for anti-tank runners. Still, grenades landed. Explosions struck steel, and often the tank continued moving. This was not because grenades were useless. A well-placed charge could disable tracks or damage external equipment. But fragmentation grenades were not designed to penetrate medium tank armor. Against reinforced hull plates, they produced shock waves and smoke, rarely penetration. Japanese officers understood this in theory. But battlefield understanding is different from watching it unfold at close range. When American forces prepared for the invasion of Iwo Jima in February 1945, specialized flame tank units were integrated into Marine divisions. The 3rd, 4th, and 5th Marine divisions would rely heavily on armored support to breach the island's underground network. General Tadamaki Kurabayashi had anticipated tanks. His defensive layout included anti-tank guns concealed within concrete casemates. But heavy bombardment prior to the invasion had degraded many larger caliber weapons. Ammunition shortages further limited sustained fire. What remained reliable were close assault teams. Japanese doctrine emphasized discipline. Soldiers were instructed to conserve explosives until certain of impact. In some cases, anti-tank squads were positioned within tunnels that opened behind likely armored routes. The goal was to allow a tank to pass, then emerge and strike from the rear. It was a dangerous method. American flame tanks altered that equation. Unlike standard Shermans that might pause to fire high-explosive shells into bunker apertures, flame tanks advanced deliberately toward cave mouths. Once within range, the nozzle, often disguised within a standard gun barrel housing, would discharge a stream of ignited fuel directly into the opening. Flame did not require precision detonation. It flowed. It adhered. It consumed oxygen within confined spaces. Inside tunnels, the effects were devastating. Reports from Iwo Jima describe caves continuing to burn for hours after a single flame burst. Thick smoke forced defenders deeper into passageways, sometimes sealing escape routes. From a tactical standpoint, flame tanks reduced the need for repeated frontal infantry assaults. From a psychological standpoint, they introduced something that standard artillery had not: visible, unstoppable destruction at close range. Japanese officers were trained in courage, endurance, and sacrifice, but they were also trained to evaluate battlefield realities. When grenades exploded harmlessly against advancing armor, when tanks ignored blasts and closed distance steadily, a realization emerged. Close assault tactics required the tank to fear the infantryman. But these new tanks did not hesitate. They absorbed shock. They advanced through smoke. They projected fire into the earth itself. And on islands like Okinawa in April 1945, the pattern would repeat. Cave systems, grenade assaults, tanks that did not stop. The balance between man and machine had shifted. What had once been a desperate but viable anti-tank method was becoming a fatal gamble. And Japanese officers watching their explosive charges fail began to understand that the battlefield was no longer reacting to their doctrine. It was overwhelming it. Inside the M4A3, or three-flame tank, space was narrow. The air smelled of oil, fuel, and sweat soaked into canvas uniforms. The crew could hear everything: the rattle of small arms fire against armor, the hollow clang of shrapnel, the thud of grenades striking steel. Flame tank crews were not ordinary armored units reassigned at random. Many volunteered. They understood their role. They would be primary targets. Japanese defenders quickly learned that the tank with the short, thick barrel was not firing standard shells. It was something worse. Once identified, flame tanks drew concentrated fire. Crewmen described the sound of grenades exploding against the hull as violent, but often dull, a concussive shock that reverberated through the steel plates, but rarely penetrated. The tank rocked. Dust fell from interior weld seams. The driver kept his foot steady. The commander watched through a narrow periscope, searching for movement near the tracks. They advanced at walking pace because coordination with infantry required precision. Marines followed closely behind, and alongside, rifles trained on potential anti-tank attackers. The tank was not independent. It was the spearhead of a combined assault team. Still, danger was constant. Japanese soldiers frequently waited until the last possible second. They emerged from hidden tunnel exits only a few yards away. Some attempted to climb onto the tank to drop explosives into open hatches. Crews were trained never to open their hatches during active engagement. Visibility suffered. Heat intensified, yet they continued forward. For these American crews, survival depended not on speed, but on consistency. They trusted the thickness of their armor and the modifications made to reduce catastrophic internal fire. They trusted the Marines guarding their flanks. And perhaps most of all, they trusted momentum. Stopping meant vulnerability. Continuing meant control. On the other side of the battlefield, Japanese officers observed the same events from bunker apertures and underground command posts. Imperial Japanese Army doctrine placed immense emphasis on moral strength. Soldiers were expected to close with the enemy. Anti-tank instruction manuals outlined how to approach armored vehicles from blind angles. Grenades were to be thrown in coordinated volleys. If necessary, men were to sacrifice themselves to disable tracks. This was not blind fanaticism. It was tactical adaptation in the absence of heavy equipment. At earlier stages of the war, close-range explosive attacks had disabled lighter vehicles and caused American armor to withdraw temporarily. But by 1945, on islands like Iwo Jima, the pattern was changing. Reports from Japanese survivors later indicated that grenades often produced little visible damage against reinforced Shermans. Smoke would rise. The tank might pause briefly. Then it would resume its advance. For officers responsible for holding defensive sectors, this created a growing dilemma. Anti-tank guns were limited. Ammunition was finite. Infantry explosives were abundant, but increasingly ineffective against upgraded armor. And the flame tanks did not merely destroy bunkers. They rendered them uninhabitable. The psychological impact was profound. Concrete and volcanic rock provided protection from shrapnel. They did not provide protection from flame forced through narrow openings under pressure. Officers who had spent months preparing defensive grids began witnessing entire cave systems neutralized in minutes. Anti-tank teams that rushed forward with grenades were often cut down by accompanying Marine riflemen before reaching their target. Those who succeeded in throwing charges sometimes saw the tank continue advancing anyway. Courage remained. Determination remained. But certainty began to erode. Technically, fragmentation grenades were never designed to defeat medium tank armor. Their lethality derived from blast and shrapnel dispersion, not shape charge penetration. Japanese grenade bundles increased explosive force but did not fundamentally alter penetration capability. Against lightly armored vehicles, the combined blast could disable exposed components. Against the 2 to 3 inches of rolled homogeneous armor on late-war Shermans, often reinforced further with field modifications, the effect was limited. Tracks were vulnerable, but hitting a moving track required precise timing. Moreover, American tactical evolution reduced opportunities. Infantry screening prevented many Japanese soldiers from reaching throwing distance. Flame tanks rarely advanced alone. Engineers cleared paths. Rifle squads secured flanks. Machine guns suppressed cave entrances. Even when grenades detonated successfully, the internal configuration of newer Shermans reduced catastrophic damage. Wet stowage systems surrounded ammunition racks with water jackets, lowering the chance of ignition from shock. The result was cumulative. Japanese anti-tank doctrine relied on the expectation that explosive shock would at least halt an armored vehicle. A halted vehicle could then be destroyed more easily. But these flame tanks did not reliably halt. They absorbed the concussion. They maintained engine speed. They closed distance deliberately until the flamethrower nozzle aligned with its target. And once within range, the defensive advantage shifted entirely. The clash was no longer infantry versus machine. It was time versus exposure. Every second a tank remained operational increased the probability that the bunker would be neutralized. 4 Japanese officers monitoring sectors through field telephones and signal runners. The pattern became undeniable. The weapon they depended upon most, the grenade in the hand of a determined soldier, was losing its decisive power against this advancing steel. And that realization spread across multiple islands as the war moved closer to Japan's home waters. The M4A3R3 flame tank was not simply a Sherman with a different weapon. It was the product of battlefield learning. Its flamethrower system replaced the main 75mm gun with a projector assembly disguised within a shortened barrel housing. To an observer at distance, it still looked like a conventional tank. This deception bought seconds, sometimes minutes, before defenders realized what they were facing. Inside the hull, cylindrical fuel tanks stored thickened gasoline mixtures under pressure. Nitrogen gas systems forced the fuel through reinforced lines toward the projector. Ignition systems ensured that the stream burst into flame as it exited the nozzle. Range could exceed 100 yards under optimal conditions. But most engagements occurred at far closer distances, often 30 to 60 yards from cave mouths or bunker slits. Armor protection was critical. By 1945, many Shermans in the Pacific featured additional welded plates over vulnerable frontal areas. Spare track links were mounted along hull sides to add improvised thickness. Sandbags were sometimes stacked for extra shielding, though these offered limited ballistic value. Wet ammunition stowage, introduced in late production models, dramatically reduced the likelihood of ammunition cooking off after impact. This innovation alone increased crew survival rates significantly in comparison to earlier war variants. The engine, a Ford GAA V8 in many M4A3 models, delivered consistent torque even under heavy load. In volcanic sand and uneven terrain, steady power output mattered more than speed. The entire design philosophy centered on one idea: approach under fire, endure, and deliver overwhelming close-range effect. Japanese grenades were powerful against men. They were limited against steel engineered specifically to resist concussive shock. In purely mechanical terms, the confrontation was unequal. But warfare is not decided only by engineering diagrams. Artillery destroys through impact. Flame destroys through presence. When a high-explosive shell strikes a bunker, there is a flash and a shockwave. When flame is projected into a confined cave, it lingers. It consumes oxygen. It ignites materials within reach. It produces smoke that fills passageways long after the initial burst ends. For defenders inside the tunnel systems of Iwo Jima and later Okinawa, this was not simply another form of bombardment. It was an intrusion into what had been considered secure space. Japanese defensive planning relied on depth. Tunnels allowed troops to survive preliminary shelling and re-emerge. They could shift between firing ports. They could reoccupy positions thought destroyed. Flame changed that calculus. A single projection into a cave entrance could render the immediate chamber uninhabitable. Even if structural collapse did not occur, heat and smoke forced movement deeper underground. Communications faltered. Ammunition supplies stored within reach could ignite. Officers responsible for maintaining morale faced a new challenge. Courage could compel a soldier to charge a tank with grenades. Courage could sustain a position under artillery. But flame entering a confined space attacked instinct itself. The reflex to breathe, to escape heat, to avoid suffocation. American after-action reports documented defenders abandoning outer tunnel chambers after repeated flame assaults. Some positions were found burned out entirely. Others were discovered silent, their defenders having retreated beyond reachable sections. The terror described in later recollections was not theatrical exaggeration. It stemmed from unpredictability. A grenade thrown at a tank produced a known outcome. Explosion, smoke, perhaps damage. A tank projecting flame into a cave produced effects that extended beyond sight. And when grenades failed to halt the tank before that moment arrived, the psychological advantage shifted permanently. Flame tanks were not introduced casually. Their use reflected the grim arithmetic of Pacific warfare. On islands like Peleliu, American forces suffered severe casualties clearing fortified ridges and caves without sufficient armored flame support. The terrain favored defenders who refused surrender. By 1945, U.S. commanders concluded that reducing friendly losses required overwhelming force against fixed positions. Flamethrower tanks were integrated deliberately into assault plans. They were used to neutralize positions that would otherwise demand repeated infantry charges. The result was destructive efficiency. Entire bunker networks could be silenced in hours rather than days. But the cost was visible. Burned fortifications, blackened rock, equipment fused by heat. Japanese officers understood the strategic implications. If fortified islands could be cleared methodically by armored flame support, the defensive doctrine built around attrition would erode. The expectation had been to inflict such heavy losses that American political will might falter. Instead, new technology reduced the time defenders could hold. In purely military terms, flame tanks represented adaptation. In human terms, they represented escalation, a sign that the war had reached a stage where every method of neutralizing resistance was being employed to shorten the path toward Japan's home islands. For the officers observing from underground command posts, the pattern was unmistakable. Grenades detonated. Tanks advanced. Flame followed. And with each bunker neutralized in this manner, a deeper realization formed that the decisive moment of confrontation was approaching, when courage alone would not compensate for the growing imbalance between industrial power and isolated garrisons. That decisive moment would arrive not gradually, but in a concentrated clash on the black sands of Iwo Jima. February 1945. Northern Iwo Jima. The early landings near Mount Suribachi had secured the southern end of the island, but the real defensive core lay to the north, a maze of ridges, draws, and interconnected tunnel systems. Marines advancing inland encountered resistance that did not break, only shifted. One such stronghold lay within the jagged ground near Hill 382, later nicknamed the Meat Grinder. Here, Interlocking fields of fire from concealed positions halted infantry advances repeatedly. Artillery support suppressed visible openings, but firing resumed once the barrage lifted. Flame tanks were ordered forward. Among them were M4A3, or 3 Shermans attached to Marine tank battalions supporting the 4th and 5th Marine Divisions. These vehicles had already proven their value in clearing fortified positions along the island's southern approaches. Now, they were directed toward one of the most stubborn defensive nodes on the battlefield. The terrain was punishing. Volcanic sand gave way to broken rock. Craters overlapped. Burned-out vehicles marked earlier attempts. Engineers moved ahead cautiously, probing for mines. Rifle squads advanced in staggered formation, scanning for sudden movement from hidden apertures. The flame tank moved at steady speed. Not fast, never fast. Its commander watched through a periscope, identifying suspected cave mouths along the slope. Inside the Japanese defensive grid, officers relayed instructions through field telephones buried within the tunnel system. Anti-tank teams were positioned near secondary exits. Grenade bundles had been prepared in advance. The first grenade struck the hull near the right side track. A concussive blast erupted against the steel. Smoke burst outward. The tank lurched slightly, but did not veer. Marines flanking the vehicle immediately opened fire toward a narrow slit in the rock from which a figure had emerged. A second explosion followed. Japanese soldiers had rushed from a concealed position behind a rocky fold. One hurled a cluster of grenades beneath the front glassy plate. The blast lifted dust and sand high into the air. Shrapnel pinged against spare track links welded to the hull. The engine did not stall. From inside, the crew felt the shock ripple through the frame. Instruments trembled. The driver maintained throttle. The commander scanned for track damage. None was visible. The tank continued forward. To the Japanese anti-tank team, the expectation had been interruption. A halt. Smoke indicating internal fire. Instead, they saw the machine close distance deliberately, as if indifferent to the explosions. At approximately 40 yards from the cave entrance, the tank rotated its turret. The shortened barrel, easily mistaken for a conventional cannon at distance, angled downward. Then the projection began. A stream of ignited fuel surged outward, arcing directly into the cave mouth. Flame entered the darkness with force. Thick black smoke followed. Marines advanced behind the tank, rifles raised, firing into secondary openings to prevent counter-assault. Inside the tunnel network, heat intensified rapidly. Communications faltered. Sections of the outer chamber ignited. Ammunition stored near the entrance began to cook off in sporadic bursts. Japanese officers monitoring the sector received fragmented reports. Grenades had been deployed. The tank had not stopped. Fire was entering the main aperture. Attempts to launch additional grenade assaults were met by suppressive fire from accompanying infantry. One soldier managed to approach within throwing distance and detonated a charge near the rear hull. The blast shook the vehicle but failed to disable it. The tank maintained position long enough to deliver sustained bursts into multiple openings. Within minutes, what had been an active defensive node was reduced to smoke-filled chambers. Surviving defenders retreated deeper into the tunnel complex, abandoning the outer positions that had stalled Marine infantry for days. The ridge did not fall instantly, but a critical segment of its defense had collapsed. Observers from neighboring sectors could see the pattern. Grenade attacks had not halted the armored advance. Flame had forced withdrawal where artillery alone had failed. 4 Japanese officers tasked with holding the line. The implications were stark. Close assault anti-tank doctrine, built on courage and proximity, was failing to produce decisive results against these reinforced flame vehicles. And as the day continued, similar engagements unfolded along adjacent ridgelines. The balance was shifting in real time. By the final week of February 1945, the battle for northern Iwo Jima had become a contest measured in yards. Every ridge concealed another firing position. Every crater masked a tunnel exit. Yet the methodical integration of infantry, engineers, artillery, and flame tanks was slowly unraveling General Tadamaki Kurabayashi's defensive design. The engagement near Hill 382 was not an isolated moment. It became a pattern. Flame tanks were deployed in coordinated teams, often two at a time, supported by rifle companies moving tightly along their flanks. When one vehicle drew fire, the second maneuvered into position. Engineers followed with demolition charges to collapse tunnel entrances after flame assaults forced defenders inward. Japanese anti-tank teams continued to attack. The courage did not disappear. In several documented instances, soldiers managed to disable Shermans by striking exposed tracks or using heavier satchel charges. Some flame tanks were lost during the battle, but the ratio was changing. The key difference was survivability. Late-war Shermans in the Pacific were better armored and tactically integrated than their earlier counterparts. Wet stowage ammunition systems reduced catastrophic explosions. Infantry screens reduced the likelihood of successful close assaults. And when grenades detonated without halting forward motion, the psychological edge slipped away. Japanese officers observing from underground command posts began issuing revised instructions. Anti-tank teams were told to concentrate on tracks specifically, to aim for immobilization rather than destruction. But immobilization required proximity, and proximity meant exposure to coordinated marine fire. The cycle repeated. A tank advanced. Grenades exploded against its hull. Smoke and dust briefly obscured it. Then the machine reemerged, still moving. From a tactical standpoint, this persistence shortened engagements dramatically. Positions that might have resisted for days under conventional shelling were neutralized in hours when subjected to direct flame assault. As March approached, American forces tightened their grip on the northern sectors of the island. The terrain grew even more confined. Japanese defenders retreated into deeper tunnel segments, abandoning forward apertures that had once formed the backbone of their defensive grid. General Kurabayashi's strategy had been designed to inflict maximum casualties and delay American consolidation of the island. It succeeded in inflicting heavy losses, nearly 7,000 American dead by the battle's end, with over 20,000 wounded. Japanese losses were even more severe, with the vast majority of the approximately 21,000 defenders killed. But the flame tanks accelerated the erosion of outer defensive rings. By early March, coordinated armored flame assaults contributed significantly to the reduction of remaining fortified nodes. Reports from Marine units described caves continuing to burn internally long after initial projection. Engineers would later seal entrances with explosives to prevent reoccupation. Japanese officers who survived the early days of the northern defense recognized that their anti-tank grenades, once relied upon as equalizers, could not consistently halt the advancing steel. The weapon that demanded proximity was now meeting vehicles engineered to endure that proximity. The decisive shift was not a single explosion or breakthrough. It was cumulative realization. When grenades failed to stop flame tanks at critical choke points, defensive timing collapsed. When flame entered tunnel networks, depth became liability instead of strength. When tanks continued advancing despite blast shock, confidence in close assault doctrine diminished. By March 16, 1945, organized resistance on Iwo Jima was declared officially ended, though isolated fighting persisted for days afterward. The island was secured. The airfields it contained would soon serve as emergency landing sites for damaged B-29 bombers returning from raids over Japan. The ridge that once held firm under artillery had yielded under sustained armored flame assault. And in yielding, it marked a broader transformation in Pacific warfare. a moment when industrial adaptation overcame fortified endurance. The grenades had detonated. The tanks had not stopped, and the consequences of that imbalance would extend beyond a single volcanic island. When Iwo Jima was declared secured on March 16, 1945, the island no longer resembled the fortified stronghold General Tadamaki Kurabayashi had once commanded. Its ridges were scar-black. Concrete pillboxes were split open. Cave mouths were sealed with collapsed rock and demolition charges. The volcanic landscape, already harsh, now carried the residue of weeks of bombardment, close-quarters combat, and concentrated flame assaults. The cost had been immense. Of the roughly 21,000 Japanese defenders stationed on the island, only a few hundred were captured alive. The vast majority were killed in action or died within the tunnel systems. American forces suffered approximately 6,800 killed and more than 19,000 wounded, one of the highest casualty rates of the Pacific Campaign. Flame tanks were not solely responsible for victory. Artillery, naval bombardment, infantry assaults, and air support all played decisive roles. But after-action reports from Marine units repeatedly emphasized the effectiveness of armored flamethrowers in neutralizing heavily fortified positions. Where high-explosive shells cracked concrete, flame cleared the interior. Engineering units documented caves that remained hot and smoke-filled hours after initial projection. Some tunnel systems were found partially collapsed from internal explosions triggered by ignited ammunition stores. Others were abandoned deeper within, defenders having retreated beyond usable supply lines. For Marine infantry, the presence of flame tanks altered the tempo of assault. Positions that once required repeated frontal attacks could now be approached methodically. Tanks would advance under covering fire, deliver sustained bursts of flame into apertures, then withdraw slightly as engineers sealed entrances. This process did not eliminate danger. Japanese defenders continued to resist fiercely until the final days. Snipers operated from concealed recesses. Isolated machine gun nests reopened unexpectedly. Close assault grenade attacks never fully ceased, but their impact diminished over time. Anti-tank grenades remained capable of disabling tracks or damaging external fittings. Several Shermans were lost during the battle. Yet the overall effectiveness of Japanese close assault tactics declined as American combined arms coordination improved. Post-battle assessments indicated that flame tanks destroyed or rendered unusable hundreds of fortified positions across the island. Exact numbers vary by source, but the consensus among military historians is clear. Armored flamethrowers significantly reduced the duration and repetition of certain engagements. The psychological dimension was harder to quantify. Survivor accounts from Japanese personnel captured after the battle suggested that flame assaults were among the most feared elements of American attack. Not because they were unfamiliar. Flamethrowers had been used earlier in the war, but because tanks could deliver them repeatedly from protected positions and withstand initial explosive retaliation. This shifted defensive calculations. On earlier islands, such as Saipan and Peleliu, cave networks had prolonged fighting for weeks under conventional bombardment. At Iwo Jima, similar networks were systematically reduced by coordinated flame tank deployment. Strategically, the capture of Iwo Jima provided the United States with emergency airfields for B-29 bombers operating against the Japanese mainland. Over the remainder of 1945, thousands of damaged aircraft would land there after missions over Tokyo and other cities. But beneath the logistical importance lay a tactical evolution. Japanese officers studying the battle's outcome could no longer rely on the assumption that close-range explosive assault would consistently halt armored penetration. Grenades had not vanished from effectiveness, but they no longer guaranteed interruption. And once an eruption failed, flame followed. This realization would echo forward into the next major campaign. The invasion of Okinawa, in April 1945, where similar defensive systems awaited and flame tanks would again play a decisive supporting role. April 1st, 1945, Easter Sunday. American forces landed on the western beaches of Okinawa under Operation Iceberg. Unlike Iwo Jima, the initial landings were almost unopposed. The beaches were quiet. Artillery did not erupt immediately. It was a familiar silence. Japanese Commander General Mitsu Ushijima had adopted a defensive doctrine similar in principle to Kurabayashi's. Rather than contest the shoreline, his forces withdrew inland, fortifying the Shuri Line, a complex defensive network of ridges, caves, reinforced bunkers, and concealed artillery positions across southern Okinawa. The terrain was different from Iwo Jima's volcanic cone. Okinawa was larger, greener, and more varied. But the underlying structure of resistance was the same: depth, concealment, endurance. And once again, armored flamethrowers were integrated into American assault formations. Lessons from Iwo Jima were not theoretical. They were immediate. Flame tanks were deployed deliberately against fortified cave systems along the Shuri defensive belt. Infantry tank coordination had improved further. Engineers refined techniques for sealing tunnel entrances after flame projection. Japanese anti-tank tactics remained grounded in proximity. Soldiers armed with grenades, satchel charges, and explosive packs attempted to close distance with advancing Shermans. In the dense terrain of Okinawa, opportunities for ambush were even more frequent. And yet, the mechanical reality persisted. Grenades detonated against reinforced hulls. Shock waves reverberated through steel. Tracks were occasionally damaged. Tanks were sometimes immobilized, but many continued forward despite blast impact. The repetition of this outcome deepened its effect. Japanese officers faced a growing imbalance. Their defensive doctrine relied on exhausting the attacker through attrition. But flame tanks shortened engagements that would otherwise demand repeated infantry assaults. Caves once thought secure became liabilities when filled with ignited fuel and suffocating smoke. By May 1945, the Shuri Line began to collapse under sustained pressure. Artillery, naval gunfire, air strikes, infantry assaults, and armored flame support combined into a relentless advance. The human toll was staggering. American casualties during the Battle of Okinawa exceeded 12,000 killed and over 35,000 wounded. Japanese military deaths were estimated at more than 75,000, with tens of thousands of Okinawan civilians also caught in the devastation. Flame tanks were one element within this larger catastrophe, but their tactical contribution was unmistakable. After-action reports once again highlighted their role in neutralizing entrenched positions that resisted conventional shelling. Japanese defensive expectations continued to erode. The grenade in the soldier's hand had once symbolized immediate, personal counterattack against armored threat. It required courage, proximity, and sacrifice. In earlier campaigns, it had at times forced tanks to withdraw. By the final months of the war, that equation had changed. American industrial production had delivered thousands of Shermans to the Pacific theater. Modifications improved survivability. Infantry coordination reduced vulnerability to close assault. And flame systems transformed the tank from a mobile gun platform into a bunker-clearing instrument. The imbalance was no longer merely tactical. It was systemic. As Okinawa fell in late June 1945, Japanese high command faced an unavoidable question. If fortified island defenses could not halt American armored penetration, what would happen on the Japanese mainland itself? This question weighed heavily in Tokyo. Within weeks, strategic decisions at the highest levels of government would accelerate toward a conclusion no defensive doctrine could withstand. The grenades had detonated across multiple islands. The flame tanks had kept advancing, and the Pacific War was entering its final, irreversible chapter. The story of flame tanks on Iwo Jima and Okinawa is not one of spectacle. It is a study in adaptation, engineering, and the relentless calculus of modern warfare. What began as an experiment, mounting a flame projector on a steel hull, became a solution to a brutal human problem: how to neutralize enemies concealed within fortified positions without sacrificing hundreds of infantry lives. In those moments, engineering met human courage. Tanks absorbed blasts that would have killed soldiers, projected fire into the earth, and forced a redefinition of battlefield reality. 4 Japanese officers, watching grenades fail against advancing steel, was more than tactical frustration. It was a confrontation with the limits of doctrine under the weight of industrial and technological power. Training, discipline, and courage remained steadfast, yet they were rendered partially moot by innovation that exploited predictable defensive patterns. For the Marines, flame tanks were both instrument and symbol: protection, mobility, and the terrifying power to reduce fortified obstacles to ash and smoke. The human cost remained high, but the tools of war had shifted the balance, creating a tactical advantage that could no longer be ignored. Beyond the immediate battlefields, the lesson reverberated. Warfare was no longer purely about courage or numbers. It was about adaptation, about leveraging technology to reshape the psychology of defense. It was about recognizing that in the crucible of combat, survivability, firepower, and momentum could alter the outcome more decisively than even the bravest soldiers on either side. In the end, the flame tanks did more than clear tunnels and pillboxes. They demonstrated the evolution of combat itself, a stark reminder that ingenuity and persistence can redefine what is possible, even amidst the most determined human resistance. The grenades had detonated. The tanks had not stopped, and history, in its volcanic crucible, had moved forward.